This problem is applying transformations with logarithms. So to review how to graph a logarithm, we have a function, it's called an exponential function. Notice my logarithm is base 4, so my inverse function is also base 4. So when we were graphing logarithms without any transformations, we were graphing the inverse function first and finding those ordered pairs. So we're going to find the ordered pairs of the function 4 to the x power. So I'm just going to find 3 of them. Negative 1, 0, and 1 is my domain. So I substitute negative 1 in for 4, or 1 in for x, and I get 1/4. I substitute 0 in for x, and I get 1. Substitute 1 in for x, and I get 4. Now reviewing, this is what it would look like as a graph, as an exponential of base 4. To graph its inverse function, f of x equals log base 4 of x, we take these ordered pairs right here and we flip-flop them. So 1/4, negative 1, 1, 0, 4, 1. So let's just graph that logarithm without the transformation yet in the red. So we go over 1/4, down 1, over 1, up 0, over 4, up 1. So there is my blue function. Now let's look and see what happens when I subtract 4. So if you turn to page 538 in the Algebra 2 textbook, what this does is it shifts all ordered pairs in the blue to the right 4 units. You have to think opposite. So now you can either recreate a set of ordered pairs again or just shift. So this point would shift 4 to the right. 1, 2, 3, 4. So here's my first point. This point would shift 4 to the right. So 1, 2, 3, 4. And then my last one, this point would shift 4 to the right. So 1, 2, 3, 4. Or just change your x values by +4, and you'll have your ordered pairs. Our last problem that we're going to graph is just what happens if you have a base 7 logarithm. So if you have a base 7 logarithm, just like this logarithm of base 4, you want to graph its inverse function first. I'm just going to make this a little bit smaller. Alright, so what would be the inverse function? Its inverse function would be 7 to the x power. So let's find 3 ordered pairs. 7 to the negative 1 would be 1/7. 7 to the 0 would be 1. And then 7 to the 1 would be 7. Now let's not take the time to graph its inverse function. We've kind of seen a lot of those inverse functions of the exponentials. We're going to now graph its exponential, or its logarithmic. So just interchange these ordered pairs and graph. Over 1/7, down 1, over 1, up 0, over 7, up 1. The last example has a few transformations to it. It has a reflection about the x-axis. It's going to be shifting left 2 and then up 3. So to help guide you with this question, you want to do like we did this problem here, where we first create its exponential function, then flip-flop the ordered pairs to find the logarithm, and then apply those transformations. So then we would move it left 2, up 3, and then reflect it about the x-axis. And then 7.7 on page 541. you'll find out the problems in class.